Hi, today we'll be solving a chemistry past paper, a breakdown and a breakthrough and how to solve it. The code is 0620 for IGCSE, not GCSE. So number one, state the name of process that is used to separate oxygen from liquid air as distillation because it's used different boiling points of liquid. Number two is chromatography to separate the individual dyes. Produce ethanol from simple sugar. Simple sugar is glucose. When we say glucose, we think of fermentation immediately. Number four, obtain water from sodium chloride. We have evaporation and crystallization because it contains water. At the precipitate form, when aqueous silver nitrate, aqueous sodium chloride. So when we have silver nitrate and sodium chloride, we would make silver chloride, which is a white precipitate. A precipitate is a solid formed in two solutions combined, and this precipitate is insoluble, so we could use filtration for that. B. Say what it means with the term element. Substance that cannot be broken down since it is made by similar atoms. For example, the first element I thought of is sodium or potassium. Compounds are elements that bonds with each other, and ions are atom that gains or loses an electron. It is also a charged particles. Isotopes. Elements that have similar protons and electron number but different neutron number. So we complete the table which give information about carbon atoms and silicon atoms. Here we have the nucleon number is 6. We know carbon is 12 and 6, and we know silicon is 14 and 28. Here we have the electronic structure is 2 and 4, because 2 plus 4 is 6. Also, the number of proton and neutrons are the same because they're not an isotope. Similar for silicons, we have 14 and 14 here. Electronic structure would be 2, 8, and 4 because 2 plus 8 is 10 and plus 4 is 14. Name a type of bond which presents silicon atoms. Silicon is in group 4, so which it has covalent. Two physical property of silicons. Here, number one is not a conductor because it doesn't have floating electrons in order to be conducted or floated or picked up by others. Property is hard because it has strong bond. Explain how carbon monoxide is formed. Carbon monoxide we know is CO and is formed by incomplete combustion. I'm going to type this out because it is easier to type out. State from the 2 mark because we have two keywords. The keyword number one is incomplete combustion, and number two could be of fossil fuels. Here, state why carbon monoxide should not be inhaled because it is toxic to humans. State the test structure which the following compound has. Carbon dioxide, which have a weak structure. It is not very strong because it is a gas. It is very weak. It doesn't have very strong bond holding each other back. Weak bonds. Silicon oxide is also a covalent bond, but it is solid, which means it has strong bonds. Strong bonds that hold each other together. Use the knowledge of structure and bond to explain why carbon dioxide at room temperature. No, structure and bonding. Structure and bonding. We have carbon dioxide as room temperature, and because silicon oxide has stronger bonds, stronger intermolecular bonds. I don't know why I keep scrolling away. The bonds which hold atoms together, hence solid. Hence it is solid because solid has structure really close and really tight together. Yes? And we have CO2 is a gas because it has weak intermolecular bonds, hence gas. We could check our answer with the mark scheme here. Let's see. It has weak forces of attraction between moleculars. Yes, we have one mark for it. We have strong covalent bonds. It's strong. And oh, we're missing one. So force of attraction here. Hence gas. So we have 2 out of 3 marks already. To earn the final mark, we could explain why it's weak. Because it is weak, it needs little energy to break it apart, to break CO2 apart. Silicon oxide is an acidic oxide. Okay, so we have silicon oxide, and AQ is sodium hydroxide. And so sodium hydroxide is a base, and acid. Acid plus base would make water and salt, right? We have water, and let's see. Acidic oxide that contains ions, that ion. Write a chemical equation for this. We know it makes water, and we know it makes salts. Let's see what is left. We would have this left, we would have this left, and we would have oxygen left because we haven't used all the oxygen for water yet, right? Now let's balance it. So how many oxygen we have here? 2. We have 2 over here, so it's change here on 2. 2 over here. 2. Okay, which needs 2 silicon. I think this is balanced. If it's not balanced, I will recheck. Let's see. 4. It's not 4 yet, so let's rebalancing this. 4 plus 2, 2. Oh, I'm missing 3 over here. NaSiO3. So we would have 2 over here, 2 Na over here. Na2 is not 2 Na, it's Na2. And yeah, I think it is balanced. Let's check. 2, 2, 1, 1, 3. So we have 2, 4, 4. Okay, it is balanced. Good. State the temperature and the pressure used in the Haber process. So we know the temperature is 400 degree. (400 to 450 degree, 450 degree to be exact, and the pressure would be because the forward reaction is exothermic. We know the forward reaction is exothermic, so we need the low temperature for the highest yield. Yes, and the pressure would be 200 atm. Name the catalyst used in the Haber process. The catalyst is iron, Fe. The ammonia you produce in the Haber process can be oxidized to nitrogen oxide at 900 degrees. The reaction is exothermic. This is 12. This would make 12. think this would be 6. 4 NO. So it's 10 here, so it's 5 over here. And the cost greater. If it's greater, then low yield, because the fourth reaction is exothermic, isn't it? If it has a too high temperature, the yield be low. The temperature is not used because the catalyst would not work. The catalyst for this would not be able to work. Or the temperature less than 600 degrees is not used. I believe it is the oxidized nitrogen oxide at 900 degrees. Oh, oops. So, natural lesson. It's not the optimal temperature. Not the optimal temperature for it to happen. Too low would not make anything. Nitrogen oxide and nitric acid as the only product. This is our equation. Describe how you would prepare a dry sample of copper nitrate crystal in the laboratory using dilute nitric acid and solid copper carbonate. So we have, this is a nitric acid and copper carbonate. The reaction would make salt. Let's see. And let's see. Is it a salt? Because we know anything with carbonate at the end would produce carbon dioxide. Yes? Let's check. This is the chemical equation for the reaction. So here we have prepare a dry sample. So we prepare nitric acid and copper carbonate. We mix them together. But we also have to keep in mind that we we put copper carbonate as an excess to make sure all the nitric acid has reacted. So after we have all the we have the excess and we filter the solution for excess, filtrate the solution. And after that, after we filter, we mix together, and we would copper nitrate crystals here mix together, and we would heat up the solution to crystallization point. Crystallization crystallization point to create crystals of copper nitrate. When then we dry the solution, we dry the crystals. Once all the water has evaporated, and we dry the crystals. We dry the crystal once evaporated. So here we have key steps in our answers. Let's check the mark scheme. Add copper until it stops dissolving. Yes, we have that. We filtrate to remove. Yes, we evaporate and we heat until most of the water is gone. And we leave allowed to cool, or we filter and we wash. And we also dry. Formula of here, and here's the equation. Let's check our answer. We have the equation. We have preparing to, we have put in excess. We have filtered a solution. We have filtered the solution. We have heat up to crystallization point. 1, 2, 3, 4. We have the formula of copper nitrate, and we also dry. Let's see. 1, 2, 3, 4, 5, 6. 6 out of 6. Perfect. State 3 chemical properties of transition elements. So transition elements, the property number 1 would be it has variable oxidation state. Yes, state. Number 2, would be it can be used as catalyst, because we know from the Haber process, iron is used as a catalyst, and iron is also a transition element. And number 3, it forms colored compounds. So we have 3 out of 3. 1, 2, and 3. Perfect. Copper oxide is a basic oxide, but zinc oxide is amphoteric. Describe how you obtain a copper oxide with the mixture. Both are insoluble in water. So we could react this with an acid because they're insoluble in water. We cannot mix it in water. Copper oxide reacts with acid, and zinc oxide is an amphoteric acid, means it reacts with both. That's my first idea. Or we could react this with we provide with mixture of. Okay. So let's see. Oh, so we can't do this because it reacts with both. So we can't do this. Let's see. Basic oxide. But zinc is an amphoteric oxide. Amphoteric knows it reacts with both. Oh, okay. So since zinc is an amphoteric oxide, we could react zinc oxide with the base. React zinc oxide with the base. For zinc oxide to dissolves in the base. React with the base. Number two, we could obtain a sample of copper oxide in this mixture. Since copper oxide is a basic oxide, which means it won't react with the base, which we could get rid of zinc oxide before, and then we filtrate the copper oxide. Let's see. Let's write our answer. If it's right or wrong, it's fine. And we will check it at the end. Let's see. Here it reacts with oh, we all got it right. We got it right. We react with a base. Zinc oxide dissolves, but copper oxide does not. So we filter it out. So yeah, this answer is correct. 3 cells are set up using stone metals. Two metals. Right, the half ionic occurs at a zinc. We know zinc is positive, so it goes to the negative side. Oh, electrolyte in cell number 1. Let's check our answers. Oh no, it's not the right one. Oh, it has to be on the right hand side. Okay. So this is the cathode, the anode. So ionic zinc electrode. Oh, it's an electrode, so it is here. So it has to be recurring on the right hand side. So I'm gonna teach you guys a trick to remember all the reactions. If it's reduction, it happens on the right, it happens on the left, and if it's oxidation, it happens on the right. So here we have we have zinc. We would make the zinc plus. Reduction is gain of, here, let's see. Okay, we got it right. Yay! I would not give myself a 2 out of this one because honestly, electrolysis is not my best, but I'm trying. I'm trying. Put 3 metals, copper, nickel, and zinc in order reactivity. So you know zinc, I think copper would go at the end because the least reactive. Why is there no charge? Oh, okay. 3 metals, zinc. So we here have nickel or zinc. Let's see. Nickel is here. Oh, it's not the most reactive in this cell. So I would say zinc go first and then nickel, but if it's, I would have to pull out the periodic the reactivity series for this one. Okay, let's see. Yeah, zinc go first and then nickel. Complete the labeling in cell 3 by writing the polarity plus or minus at each electrode on the circle and calculate the reading on the voltmeter. Okay, let's see. Zinc is in this side. We are electroplating. Nickel is positive. Copper is positive. So it can't be both. Let's deduce our answer using this. Copper is positive and nickel is negative. Our copper is negative and nickel is positive. Okay, let's check our answers. Copper is positive and nickel is negative. Okay. We need to change the two sides of this. Not the best one at electrolysis because it's not my best. So I'm going to reduce the two answer by minusing each other. 1 plus 10 minus 0.51. What would I get? 0.59. Because we're not supplied with any more information, so I'm going to use this minus this. The element in group 7 are known as halogens, aqueous solution of halides. Okay, so we know it's the most reactive at the top and the least reactive at the bottom. So fluoride, chloride, bromide, iodide. Okay, chloride and bromide. Let's pull out our periodic table. Chloride goes first. It is more reactive than bromide, so there would be a reaction here. And chloride and iodine. Chloride is more reactive than iodine. Wait, no, this is less reactive, so there's be no reaction because bromide is less reactive than chloride. Bromide and iodide. Let's see. Bromide is more reactive than iodine, so they cannot displace each other. Iodine and chlorine. Chlorine is more reactive than iodine because it's higher, and bromine does. Write the chemical equation between chlorine and aqueous potassium bromide. So potassium bromide KBr plus Cl, Cl2, BKCl, and Br2. So this would be 2 and 2 over here. State the color of the precipitate of silver chloride. Is this white? The relative formula of silver chloride is calculate number of moles in 8. So we have moles equals mass over mr here. So we have mass is 2.87. We divide by the relative formula mass is 4.1 here. Let's see what moles we have. How many moles we have? 0.02 mole. Use that to deduce the number of chloride ions that produce. And the ionic equation. Where our ionic equation. To deduce the number of moles of chloride ions that produce. I think it's still the same. You could check. Yeah, it is still the same because conservative of energy. How many moles there is in here, there'd be the same amount made in the product because of conservative of energy. The amount of vanadium chloride in the sample was 0.01 mole. Deduce the whole number ratio of moles of vanadium chloride to amount of chloride ions. Deduce the number formula of vanadium chloride. So we have 1.01 and 1.02, well, 0.01 and 0.02. So one of this would be equals to of that, so it's 1 to 2. Formula of vanadium chloride. Vanadium. What is vanadium? Vanadium is V, I believe it's VCl. Well, that sounds like a funny name. VCl2. Because it's 2 of chloride would be equal to 1 vanadium. Predict the physical state of acetine as room temperature and pressure. The bottom, so it would be solid. It's the least